In this video, I'm going to do another example of the component method using a lost hiker problem. So let's say someone went off into the woods on a hike and they got lost. And they have left their travel plans with a friend just in case this happens. And so now we're the search party and we're going to go out and try and find where that person ended up based on what their path was going to be. Okay, so the first part of the trip, they were going to travel 4 kilometers, 35 degrees north of east. All right, so I'm going to draw a picture of this. Right, and I'm going to draw it to scale here. And let's say we start by drawing right here, and it's going to be 35 degrees north of east. So that's going to be this angle right here. So we're going to want to go about over there. Okay, and it's 4 kilometers, so I'm going to do just 8 centimeters to kind of keep it some scale here. Okay. So this is, and let's use a color just so we can distinguish the different vectors. So 4 kilometers, and we are 35 degrees northeast. Okay. Then they traveled 5 kilometers directly east. Okay, so directly this way, 5 kilometers, I'll draw it like 10 centimeters. Get it as. That's 5 kilometers. And then they traveled 3 kilometers, 20 degrees south of east. Okay, so here I'm going to put my protractor like this because it's going to be south of the east direction. Okay, I'm going to start at the tail of the last vector. So 20 degrees is like right here. And we'll do 6 here. Let me get another color. So that is 3 kilometers, and we're at an angle of 20 degrees. Okay? Now, the resultant vector is going to be from the tip of the first to the tail of the last, right? So where they should have ended up is over here. So, just draw it like this. Here. Okay? Now, if we just eyeball it, let's kind of make a rough estimate. So, if we look at this, this is 5, and here, I would say maybe that's like twice as long, maybe a little bit more. Let's just roughly guess. Maybe that's 11 kilometers. And if we look at the angle, it's kind of a small angle. Let's just say maybe 15 degrees. Okay? Just eyeballing it. All right? And that would be 15 degrees north of east. All right? Now we're going to use the component method in order to figure out the resultant vector, okay? Its direction and magnitude. So in order to do that, we need to figure out both the x and y components of each one of the individual vectors. So we have this and this, right? So that is the x and the y of the 4 kilometer vector. So what we're going to do is we're going to put, we'll start with x's here, so we'll call that vector ax. Okay, and then we'll do vector ay. Okay, and remember that we're going to use cosine for our x's, and we're going to use sine for our y's. Okay, so I would take the cosine of this angle is equal to the adjacent over the hypotenuse. So I'm just going to kind of write it up here so you can see. And then all of the calculations are going to be similar here, okay? So we have the cosine of 35 is equal to VAX over 4, okay? So we would just multiply by 4, okay? So that would be equal to the cosine of 35 times 4. And that gives me 35 cosine times 4. 3.27 or 3.28, so 3.28 meters. Okay. Now for the y, we're going to be using sine, so it would be the sine of 35 times 4. which gives me 2.29. Okay? Now we're going to do the components of our next vector. Okay? And this one's a lot easier, right? Because it only has one component. It does not have a y component, so we could say that vector by is 0. It doesn't go up any, it just goes over. And then our vector bx is going to be exactly 5. Okay? Oop, I put meters there. It should be kilometers, right? Kilometers. And kilometers. Alright, then we are going to do the last vector here, vector c we'll call it, and it has an x component there and a y component there. Now notice that the y component is down, so we're going to